नमस्ते विद्याओं, खुश रहिए। आई JVN Muskan Kumari from the Department of Science and Technology, and I'm working here as an assistant professor in JVWU University and Faculty of Education and Methodology. So today I will discuss more about the routing principles, in which I will discuss about the more algorithms of routing. Okay, so, to discuss these topics with you and to make it an easy way to understanding to all of you, I am just going to share some files which will help you to better understand regarding this topic. Clear? So, here is the files. Routing principles phase second. Okay. So, in the phase first of routing algorithm, I have discussed with you about the link state algorithm and the DVR algorithm and OSPF, little bit about the OSPF and sort of spark routing algorithm. Now, in this, I will discuss about the Bellman-Ford algorithm. Okay, so what is the Bellman-Ford algorithm? The Bellman-Ford algorithm computes the single source shortest path in a directed graph. Unlike the Dijkstra algorithm, it is compatible with the negative age weights. It is also compatible with the negative age weights. So, the basic idea is to repeatedly check each edge of the graphs to determine if there is a shorter path shorter path to the A's destination by using the A's. Of course, this has to be done often enough so that the shortest path is found. Okay, so the input of the algorithm in a directed weighted graph G has a vertex of this graph as source. The algorithm computes the distance to all over the vertices in these three states. Clear? So the first is here. Procedures Bellman Ford. There is had the list of vertices, list of the edges, and the vertex source also. Clear? So this implementation takes in a graph of obvious all the algorithm is implemented over the graph and represented as list of the vertices, which is also representing the list of the vertex and edges, and modify the vertex so that their distance and predecessors and attributes stored in the source code. Okay? So now what will happen here? In step first, initialize the graph for each vertex V in the vertices. You are using here the for loops. If V is source, then V dot distance equals to 0. There is no any distances covered by the source at the initial state. Clear? So else V dot distance equals to infinity. You can say that the distance with infinity either 0 or infinity. So V dot dash predecessors equals to null because V is vertex is of which source. Okay. Source start at the initial state. The source vertex distance is 0 either infinity. Okay, or the predecessors. There is no any predecessors of the source, so that is null. In that step second, what will happen? Here the relax is repeatedly. Relax is repeatedly. So for I from 1 to size of the vertex, for each is UV in A, suppose there is two vertex, one is U and then is V. So UV in A, UV is what? U. UV dot source, it means U is denoted as a source and D is the destination, UV dot destination, and you can say here if V dot destination means destinations vertex distance greater than the U dot distance source distance plus UV weight source and distance source to destinations weight. Okay, so what will happen then? V dot distance, it means destination's distance equals to source distance plus UV distance. Okay, now V dot predecessors equals to U. The predecessors or destination is source. Okay, now in the step third, what will happen? Check for the negative age cycles also. So you also make here the follow because there are the more than one vertex. So for each age, UV in age, here we are checking for the age and age is the formations by the vertex. Clear? So what is here? The mm, checking for the negative weight cycles, you are again using the U equals to UV dot source and V equals to UV dot destination. Suppose if destination is greater than U dot distance plus UV weight, then error generated and that will be like what graph contains a negative weight cycle. Clear? So it can be proven that algorithm always finds the shortest path from the source to each node of the graph which is presented in a network. The time needed is bounded by the big O and N complexity where N is the number of vertex and M is the number of edges in the graph. Routing information protocols. This is the second one. Routing information protocol is implementation of a distance vector routing protocol that was proposed in 1988 and later the revision includes RIP to 1994 and the RIPNG 1997. Also, routing information protocol use the basic matrix to measure the distance between nodes and the number of links to traverse also. Number of links to traverse also. That is known as the port. Okay. So the routing table entries in the routing information protocol consist of the one your address, destination, IP, and gateway, which is the first hop on the path to destinations, then interface, hardware interface, which is to be used, and the matrix number of hops to the destination is used. Okay, so what happened? Each node of the network has to relay its full routing table also to the each of the its neighbor node regularly. And if a node received an update, it will compare the contained matrix thus one to its on uh, stored matrix. Clear? And if we talks about the comparing of the contained matrix plus to one of its own stored matrix and also update the routing table if needed. Okay. And suppose if a node wants to send the packets to a destination, it looks up the gateway in the routing tables and the node has no need of full of informations about the topology or the architectures in which the routing algorithm uh, doing their work or perform their work. So, network topology as it only cares about the first one, okay, who are sending the data packets to. The receiving gateway then refers to its own routing table to determine the next hop and so on. The procedures will be followed in the routing information protocol. Clear? Now, what is the network failure? What do you mean by the network failure in this one? Suppose if a link or node in the network goes down, no further information are sent after three update cycles are completed without receiving routing information from another node, it is considered dead. Okay, what happening here? Please listen to my words. I am just recalling this one. That suppose there is a link or the node which is in a network which goes down directions and no further updates are seen to the any nodes After the three update of the cycle, whenever you are updating the cycles in 3 ways has completed without receiving the routing informations from another node, it is considered just like the dead node. The routing table is updated to the matrix infinity, and we are updated the routing tables for that particular nodes are like the infinity implemented by routing information protocol at 16. Okay, consider the case of three nodes in a line, suppose A to B, B to C. The routing entries for C in the table of A and B is as follows. Node gateway to C and hops to the C. Here you can see that A, A to B is 2 and B to C is 1. Clear? So, or it now if C goes down, B will update its routing table accordingly to this ones. So now node gateway to C. Now node gateway to C. Hope to C, then A to B is 2 and B is just updated their routing table, so B is infinity, that is 60. Okay, but the same time A offers a route to the C with the matrix 2 that is clearly shorter than the 16. So B will therefore update its entry to matrix 3. Okay, now, node gateway to C is will be like what, and port to the C will be A to B is 2, but B to A is 3. Okay, so this will cause A to update the matrix to 4 and so on until both nodes reach the maximum 16. This problem is called the counting to infinity, and it is the reason for choosing the 16 as the representation of infinity in the routing information protocol. And while A and B are counting to 16, packets are routed in a loop. To avoid this problem, routing information protocol implements the split horizon. This means that node do not advertise routes to the node they have stored gateway. Poisson reserves is an extension that causes the nodes to advertise routers to the gateways with the matrix infinity. This helps resolving looping in complex situations faster, but routing loops cannot be avoided together by the rig. Clear? Now, if we talk about the border gateway protocols and the destination sequence distance vector routing protocols, so these both are not too much important, but I will discuss here once again that border gateway routing protocols is de facto standard for the routing between the autonomous systems in the internet. It is basically often referred to as the path vector protocols, as the routing table entries contains the whole path to the destination and not only the first hop as in true distance vector routing protocol. The advantage in the loop detection on the one hand and also the possibilities which will help you to the implement the policies at the nodes also. Clear? And now if we talk about the distance sequence distance vector routing, so DSDV is the proposition by C. Perkins and P. Bamber for using the distance vector routing in mobile ad hoc network. This algorithm was presented in 1994, but it was never implemented. Using the distance vector routing algorithm in a ad hoc network is problematic because of rapid topology changes. The fact that mobile network use a broadcast instead of point-to-point media connections, so that the standard loop prevention techniques cannot be used. And the idea which is used in DSDV is then to let each node number its outgoing update packets to the differentiate between new and stale routers. The sequence number also gets propagated through the route. Node can therefore discard update with older number they receive. Okay, so students, this is the basic of its second part of your routing principles in which I have discussed the rest of the routing algorithm, and I hope you will understand it very clearly. And once again, please read the sessions by your own. And if you have in case any problem in this session, then please let me know your query and questions regarding this session by dropping your questions into the comment section box, through which I will discuss that topics with you in the next session, scheduled session. Okay, and please also prepare the multiple questions which may arises from this session, like what do you mean by the Bellman Ford algorithm, what is the difference between Bellman Ford algorithm and Dijkstra algorithm, explain this with an algorithm pseudocode, isn't it? When you have to write the pseudocode of Bellman code, and routing information protocol is what, isn't it? What do you mean by the network failure? You explain this with an example. What is the border gateway protocol? What is the destination required distance between routing? Okay, so these might all the questions will arise us through you through these sessions. Okay, so always be prepared with all type of the sessions. And, okay, thank you. And in the next session, I will discuss the next topics. Okay, so be prepared all the sessions and all previous sessions also. Clear?